All right, we're going to be starting chapter 7, which is on memory. This is a great chapter because I think you're going to learn a whole lot of tips and tricks that will help you optimize your memory system and also understand some of the ways that our memories are imperfect. But then, because we know how they're imperfect, we can work around that to improve our memory. So, here are our gateway questions. We're going to be going through all of these. So we're going to be starting off first talking about memory processes, starting off talking about short-term memory, working memory, and then long-term memory, as well as some disorders of memory and forgetting. I like this image here. This is actually a really famous person's brain. His name, or he was known as patient HM, but after his death, we learned that his name was Henry Molaison. Patient HM is a famous patient in psychology because he had severe amnesia after doctors removed a part of his brain. He had severe seizures, and so the doctors believed that they could cure his seizures by removing the part of the brain kind of close to the center that seemed to be responsible for producing the electrical current of the seizure. So they went in. They're like, this isn't going to be a problem. He'll wake up. He'll be just fine. So they removed the part of the brain, and he did. He woke up. He could talk. He could walk. He seemed normal, except that he couldn't form any new memories from that point on. And turns out the part that they removed, we now know is the hippocampus, which, if you remember back from chapter 2, is really important for memory storage. So they removed his hippocampus, and again, he couldn't form any new memories for the rest of his life. So doctors and researchers, they did all kinds of work studying Henry's brain and really looking at some of the finer tuned details relating to his thought process and his learning process. After he died, his family donated his brain to science, and then they plasticized it. So they put it essentially into this resin, and then using what's essentially a high-tech deli slicer, they made super, like, 1 millimeter thick slice of his brain, which were then imaged and put online. I've put a video of this slicing process for you online if you'd like to check it out. You'll never look at your cold cuts the same way again. But kind of check it out. It's pretty neat. And we're going to be talking more about amnesia, the different types of amnesia later on in this chapter. And then we're going to see a video of a patient who has amnesia just like patient HM. So going through some key terms first. Memory is our active mental system for receiving, encoding, storing, organizing, altering, and retrieving information. So some of these words are probably familiar, but some of them may be a little bit kind of odd in this context. So what we mean by encoding is that's when we're converting information into a form in which it can be retained in our memory system. So just as we talked about in chapter 4, we have light that hits our eyes, that gets turned into an image on our retina, that goes back into our brain, and when we're looking at something, whether it's letters or numbers, our brain has to make sense of those symbols, which then can be stored and organized in our brain. So that's the encoding process. It's taking things that are from the outside environment and bringing them in and putting them in a form that's going to be useful to us. Storage is when we hold on to that information in memory for later use. So we've made some sort of connection in our brain that's allowed us to hold on to that new information. We also have retrieval. That's recovering information from our storage and memory for usage. So if I'm remembering, my mom's birthday, I have to go back into my memory system, find that neural connection, and then activate that in order for me to remember that and retrieve that information when it's useful. And hopefully I won't forget her birthday. So overall, our memory system is a system by which we retain information and bring it to mind. And it's a method for retaining information and skills that we acquire through experience. So we talked about conditioning in the last chapter. These are some of the skills that we will acquire, and our brain has to hold on to that, and that's this memory system. And it goes from encoding to storage to retrieval. Encoding, again, is taking that information in, Storage is holding on to it, and retrieval is bringing that information back to mind. It's kind of like storing files in a filing cabinet. Encoding is, taking it and putting it in the filing cabinet. It's sitting in the filing cabinet is storage, and then retrieval is bringing that piece of paper back when we need it. So again, encoding is transferring information from one form to another. That could be reading into, the thoughts about what you just read. It could be listening to something. It could be seeing something or just thinking new thoughts. Storage, this is actually a really important feature of the brain, and we're going to talk more about this later on. But the really cool thing about our storage for our brain is that it's essentially unlimited. Unlike computer servers or the computer or your iPad that has limited storage, our brains can continue to learn new information, to encode new information, to hold new information for our entire lives. There is no capacity limit that scientists have found as of yet. It is highly variable based on the individual, and there's different things that are easier to store than others, but we have this remarkable capacity to continue to hold on to information. It's very, very impressive, and it's unmatched by any sort of computer technology at this point. If you've seen the movie Inside Out, this is an image of what they consider to be the long-term memory storage system. So each of these little dots represents a memory, and you can see all the memories stacked up and what kind of resembles the gyruses and sulci of our brain. I just like the way that they made the image out of this. It's very cute. Retrieval is a recovery of stored information when it's needed. The problem with retrieval is that there's no guarantee of success. That memory may be there, but we may not be able to pull it when we need it. And this could be caused by interference, so other things going on in the environment. We're going to talk about this more later on. It can also be caused by stress. So if you've ever sat down for a test after having studied all day, and then you sit down, you're like, I know this, and then as soon as that test comes out, you get so stressed out that everything just goes blank in your memory. Or you're looking at a question, you're like, I know this, but I can't bring it to mind. That's that interference that can be caused through stress. So first we're going to be talking about short-term memory, and we're going to be going through a couple different aspects of short-term memory. So first off, short-term memory starts with what we call sensory memory. So they are first and normally unconscious stage of memory, and that holds the exact record of incoming information for a few seconds or less. So as I'm talking to you and as you're watching this video, you have imagery coming in, you have sound coming in, and your brain is essentially reading through that information, and that's part of your sensory memory. Sensory memory is broken down into two major components, although it can be others, but iconic memory is the mental representation of a visual image or a mental image. Echoic memory is sound related. Echoic sounds like, an echo. That's a brief continuation of sensory activity in the auditory system after a sound is heard. So that's why, if you're kind of ignoring your parents and all of a sudden they say, did you listen to what I just told you? You can maybe repeat back the last few seconds. That's that echoic memory that's still holding essentially that echo of what you have just heard. Same thing can be if you're just looking at something quickly, you close your eyes, you can still kind of see a basic image of it in your mind for a few seconds until maybe some other thought or emotion occurs. So there's a famous model called the Atkinson-Shiffrin model. And this is a representation of how information comes from sensory input into our long-term memory storage as it travels through short-term memory. So first step in this system is sensory input. So you hear or you see something that goes into our sensory memory system, and a lot of that gets forgotten. There's a lot of things that you hear and you see throughout the day that you just don't need. If you remembered everything on your drive into school or everything you heard on the news or on the radio or in a YouTube video, your brain's just going to be overwhelmed. So most of it just gets dropped right at the very start. Things that are kind of noticed and important will go on to short-term memory. And while it's still being thought about actively, we call this rehearsal. But a lot of that also gets forgotten. So if you're watching the news and you hear a story, you're like, oh, that's kind of interesting, and maybe you think about something else that it's related to or something you heard the day before. That's part of the active rehearsal process. But if, a couple hours later you've totally forgotten about it, then it's gone. But then if you've thought about it enough, or you've made enough connections, or you've said it enough times in your head, it will go to your long-term memory system. Another example of this is, let's imagine that you are at a club and you're having fun with your friends, and all of a sudden you see this beautiful person walk up to you, and they say, hey, here's my phone number, call or text me. And so that sensory input, the sound of those numbers coming towards you, is now a sensory memory. It's important, so you're not going to forget it right away. It's going to go into short-term memory. Now, maybe your phone, you left it back at the table with your friends. You don't have anything to write it down with, so you're rehearsing the number over and over again. 954, bup, 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 bup. And you're sitting there, and you're doing these numbers over and over again in your head. But then your friend tells you, hey, you owe me this much money for our drinks tonight. Oh, no. You've had this interference, and now you've forgotten this girl's phone number. Ugh, it's the worst. But maybe you've rehearsed it enough times, or it's similar to something else, or somehow the number's really easy to remember, and it makes it into your long-term memory system, and then a few minutes later you can write it down and you can send her a text. Again, so sensory information holds a large amount of incoming information in our short-term memory for a very, very short period of time. It happens very fast. And then it moves into our short-term memory system. Also, we're going to abbreviate that as STM. The short-term memory system is used to hold small amounts of information on our conscious awareness for about 12 seconds. It can be more, it can be less, it just depends on what's going on around you in the environment. Working memory is another name for short-term memory, and it's especially it's used for when we're talking about thinking and problem solving. So what I like to kind of represent to students is that short-term memory is like a big circle, and kind of on the side within that circle is a smaller circle. It's like a bubble within a bubble. The working memory is the internal bubble. Short-term memory is the outside bubble. And working memory is a component of short-term memory, but it's kind of a more select and specialized form of it that we use for working through problems or thinking about things. So that's why it's called working memory. And one of the main ways that we hold on to information in our short-term memory system is what we call maintenance rehearsal. That's silently repeating or mentally reviewing information to hold on to it in our short-term memory. So first of all, we're going to do a quick experiment. I'm going to ask you, how many individual digits or letters do you think you can hold in your memory and repeat back in that same order? Do you think it's 5, 10, 20, 100? Maybe a really good memory. Why do you think that number is the number it is? Do you think there are certain things that can make those numbers higher or lower? What do you think? All right, so we're going to do a quick little experiment. Let me pull it up real fast. Okay. So in this experiment, what you're going to do is you're going to see a series of letters. They're going to be shown one at a time. And then afterwards, you're going to write down the letters that you saw in the exact order that they appeared. Do not write anything until you see the instructions to write it down. So you're going to come up one at a time, like one every second, and then it'll tell you to stop, and then it'll tell you to write it down. All right, so are you ready? Let's begin. Okay, how'd that go? Did you get it correct? Okay, so that's 4 digits. Trial 2, let's begin. All right, how is this one? Easy? Maybe you missed the last one or two? Let's see. All right, trial 3. Let's see how you can do. Was that one a bit harder? All right. Did you get that one? That one's pretty tough. All right, so maybe a few of you got that. I want to see if you can remember 14 letters. This is for our memory champions out there, all right? I want everyone to give it a good try. Focus, harness all your mental energy, wake yourself up for just a minute, and try this one out, okay? So here comes 14 letters. And we're going to begin. Did you get that one? All right, so maybe, hopefully, you notice there's a pattern in this one. You got the letters that make up the words, huh? All right, so that's the end of that. I'm gonna go back to our other presentation here. All right, so when it comes to our short-term memory system, one of the major ways that it's measured is through the digit span. So essentially that's what we just did, is how many letters or numbers can you remember in order without mistake. And for most people that ends up being around 7 plus or minus 2. So anywhere from 5 to 9, with 7 being the average, we consider the magic number of digit span. So what techniques did you use to hold on to those digits? Did you try to make a story out of it? Did you try to repeat it back to yourself? So starting at the beginning, so DJ, and then DJR, DJRN, DJRNQ. So did you hold them in your mind that way? Or did you, go, okay, DJ like a music DJ, RN like a nurse, QP, another similar place in the alphabet? I don't know. You may have told yourself a little story as you went along. Was there any interference for you? Did you start getting stressed out? Are you tired or hungry? Did someone make a noise? Did you have a phone notification go off? Was there any interference while you were trying to do this task? Now, if I told you to stop and wait before writing those things down, how long do you think you could have held on to those digits, especially when there was 9 of them in the sequence? Like, how long do you think you could have held on to that in your memory? And then, as you probably noticed, what was the big influencing factor on the very last one? As you probably noticed, it spelled words. So frog, pig, bat, duck made it a whole lot easier to hold on to 14 digits than it was for the 9 digits on the one before. So with our short-term memory system, we hold a small amount of information, so that's 7 plus or minus 2, for a really limited time. If I asked you to wait for even 10 seconds, you're going to be below 50% on your recall. It drops off significantly within a matter of just a few seconds. If I ask you to hold on for 20 seconds, you're practically at 0. It's amazing how quickly those things erode and just kind of fall away from our short-term memory system. We also use things like chunking. So if I just, listed off those 14 digits, it would be really almost impossible to do it unless they spelled the words. Because once you have the words, you chunk them together. So if I said DOJ, CIA, EPA, things like that, if you don't recognize that I'm talking about intelligence agencies or different departments within the federal government, you're probably going to have a really hard time remembering those things. But if you can chunk them into the groups that make sense, then it's going to make it a lot easier for you to hold on to that stream of information. That's the reason why we have phone numbers done the way that we have them. So we don't just get a string of 10 digits. We have it grouped into area code, the first 3 digits, and then the last 4 digits. Other countries do it a little bit differently. They'll group them, I think it's like, was it 332 or something like that? It just depends on how, or 3, 2, and 2, I guess it would be. They will break the numbers down differently in order to make it easier for people to remember it. Same thing happens with our social security numbers. Now, the nice thing is that, if someone gives you your phone number and they're local here, if you just said 954, immediately the person just says Broward. So instead of holding on to 3 digits, you're holding on to just one unit. If I said 305, Miami, 561, Palm Beaches, you're not going to have to remember 3 digits. You're only remembering one, which makes it a whole lot easier to hold on to vast amounts of information. Now, there's competitions out there that people will participate in where they essentially get like the same type of stimuli that you just got, but instead of letters, they have numbers. And so they'll be shown one number at a time with 1 second, displays, and they'll show them thousands of digits, and these people can repeat them back in the exact order after only one presentation, like no studying. And the champion that I know about who could do this like 1,000 or 2,000 digits. What he did is he chunked the numbers into groupings based off of running times. So he'd be like, oh, that's a good marathon time. That's a slow marathon time. That's a good 10K time. And he would be able to then group them into like groups of 4 or 6 or maybe even 8. And then from there, he could remember them. I mean, that's still pretty impressive. It's very impressive. But that's how he has this championship type memory, is that he uses chunking techniques in order to remember those long strings of digits. All right. So if you've memorized a lot of information, how much of the information are you actually able to remember? So imagine you've been studying, you're trying to get information from your short-term memory to your long-term memory system. So let's imagine you're going to take a test and you have 5 chapters of information that's going to be on this test. Maybe it's like a big final exam. So chapters 1 through 5 in the textbook. What information are you more likely to remember, and what information do you think you're more likely to forget? What do you think? All right, so we're going to do another quick experiment. Okay, so here's our experiment. You're going to see a list of words displayed one at a time. After you see the last word, you're going to be asked to write down as many of the words as you can recall. You do not have to write down the words in the order you saw them. Just get as many down as you possibly can, as quickly as you can. All right, so make sure you have a pen and paper ready for when it tells you to write it down, okay? And we're going to start. All right, stop. And now what you're going to do is you're going to count up how many words are in this first list, how many are in the middle list, and how many are in the last list, okay? So go ahead and count those up. See how many words you have in each. All right. So I'm going to take a guess that your word list, your numbers for the number in the first column, probably like 3 to 4. But in the middle, you probably have maybe one, and at the end, you have two or three. Was that kind of close? So this is an example of is a serial position effect. Now, it may not have worked perfectly because you are just one individual, but when we do this as a class, typically our averages work out to look something like this. So if we graph it, the words in the number of words in the first list is typically pretty high. The ones in the middle drop off, and then the ones towards the end and the last column are typically a little bit up again. This is called the serial position effect. So this is our tendency to make errors remembering things that are in the middle of an ordered list. And we have what's called the primacy effect and the recency effect. So the primacy effect means that these are the things that came first. They've most likely been rehearsed the most times. Your brain was clean and fresh and ready to take in the information, and they've potentially made it into your long-term memory system. The words at the end are still in our short-term memory system. They're the newest, freshest things that we just got. So we've now had a chance to write them down really quick. But the ones in the middle, those words are the ones that are more likely going to be forgotten. So if you go back to these questions here and you're memorizing a lot of information for a test, be aware of the serial position effect. Focus on studying things that come in the middle because you're more likely to remember things at the beginning and the end of the group, and you're more likely to forget the stuff in the middle. All right, so if you're in class, we're going to do a memory check on Nearpod, and you'll enter the code on the screen and take the quick little quiz. It's like 10 questions. All right, so also, in order to help us remember things and keep things in our memory system, we can use what are called mnemonics. The name comes from the Greek mythology of this, I think it's a goddess, Mnemosyne, I think is how you say her name. She's the mother of the 9 muses, and she was a personification of memory in Greek mythology. So mnemonics are any tricks that help us remember facts or large amounts of information. Maybe you've seen this trick looking at the days, number of days in the month. If you're trying to remember which months have 30 days, which ones have 31 days. If you start at your far left knuckle, it's up high, and so January has 31, and then you go down to the little dent in between your knuckles, February, then back up to March. April has 30, May is 31, June has 30, July is 31, and you go to your next one, and that's how you go through the months. Are there any other mnemonics you remember? Maybe 1492, Columbus sailed the ocean blue. What about every good boy deserves fudge? Or I've heard fun. What do you think? Do you guys know what that is? That's the musical notes on a scale. My very excited mother just served us 9 pies. That's the planets, including Pluto. I'm sure they've now adjusted that somewhere, but when I was a kid, it was 9 pies or 9 pizzas. What other ones do you guys use at all? Can you think of any that we've used in psychology or ones that you've used in other classes? So what about the phylogenetic tree? So I learned King Philip comes over for Girl Scouts, which stands for Kingdom, Phylum, Class, Family, Order, Genus, Species. We've done it with psychology where we've talked about how Broca sounds like Boca, and Broca's area is for speech production. So that's a mnemonic device. Are there any other ones you can think of? Maybe we did one for the brain waves for sleep. So like beta stands for bright-eyed and bushy-tailed. Delta was like deep asleep. So yeah, we use these quite a bit. And if you're ever trying to study large amounts of information, whether it's in this class or other classes, make sure you're trying to use these mnemonic devices. They're probably going to be quite useful for you. All right, we're going to stop here, and next time we're going to be talking about long-term memory.